Hello, everybody. In this particular video, what we're going to start with is the group mean, the group median, and the group mode. So we have here a particular problem regarding ages of drivers who met accidents last year. As you can see here, we have from 20 to 30 until 60 to 70. Now, to identify the group mean, median, and mode, we have to complete these remaining columns, the X, the FX, and the CF. Now, the X is actually called as the midpoint, or this is also called as the mid interval. Right, so the formula is very simple. We just have to add the lower bound and the upper bound, and we're going to divide the answer by 2. So here we're going to do it manually because we cannot select the values. Because as you can see, the values here are given as intervals or group data. We call this as group data because we have intervals or classes starting from 20 to 30 until 60 to 70. Okay, so again, what we're going to do is to add the lower bound and the upper bound. The lower bound is 20 here, and the upper bound is 30. And do not forget to put the open and close parentheses. And here, this is always 2. Now, for example, if you forget to put the open and close parentheses, of course, it's going to give you a wrong answer. And FX will be affected, and all your answers below will be affected. Okay, so you have to be very careful with this. Second one is 30 plus 40, close, over 2. So that is 35. Let me just make this bigger. All right, so the third one is 40 plus 50 over 2. And this will be 50 plus 60 close over 2. And here we have 60 plus 70 all over 2. So as you can see, we have a difference of 10 every time, 25, 35, 45, 55, and 65. Now, Fx means F times X. Our F is the frequency, and our X is the midpoint or the mid interval. So that would be equal to the frequency. So you have to select the frequency, multiply our X. So that would give us 450. Now, since we selected 18 and 25, we can easily drag this down. Just select the first answer and then drag it down until the last. Okay. And for the CF, this is cumulative frequency. The first CF is actually equal to the first frequency, always. Our first frequency is 18, so equals, select 18. And the second one is equal to the left. This is the left, 19, plus the first CF. Okay, so you have to get only the first 2 values. You don't need to do it again here. So you just have to select the second number and drag it down. As you can see, it keeps on adding. This is actually adding as we move along. Or CF is also called as the running total. It's adding as we move along. Right? So 18 plus 19 is 37. 37 plus 5 is 42. 42 plus 2 is 44. 44 plus 1 is 45. So that is why the total of the frequency is equal to the last CF. Because as I mentioned, this is adding as we move along. So what is the meaning of CF actually? CF actually is less than or equal to. Okay. So this is also less than or equal to. That's basically the meaning of CF. So if we're going to take 42, for example, this number here, 42, what is the meaning of this? 42 means this is the value from this upper bound until the lowest bound. So that means less than or equal to 50. But since this is actually from 40 to 49.999, okay, this value here is like from 20 to 49.999. So that means if you're going to count all the occurrences, the frequencies from 20 until here, that would be equal to 42. So that means 18 plus 19 plus 5 is correct, because 18 plus 19 is 37 plus 5 is equal to 42. So that is the meaning of CF. It is the number lower than or equal. Okay. So that means we have to add all the frequencies from that and below. So that means from 5 and below is 42 all in all. 44 means these are all the occurrences, the frequencies from this until 50 to 60 class. Okay. So that is 44 all in all. If we're going to add all of this, 18 plus 19 plus 5 plus 2, that is equal to 44, of course. So the last is 45, equal to the total here, because this includes all from 20 to 60 to 70, right? So that is why the last CF is equal to the total of the frequency. So let's now proceed to calculating the mean. The formula is given. The formula is sigma fx over sigma f. That means we're going to get the total of fx, so equals, so we have to get the total here equals sum of these values. As you can see, we have 1515. Also, you can copy this formula here and paste here. Okay, paste, copy and paste here. It's going to give you 1515. Because when you're copying any cell with a formula, it will copy the formula, not the value. Okay. You just do this. Now, for example, here, this one is blank, and you're going to copy 45. It will not copy 45 actually, because it has a formula. What is going to copy is the formula. Okay, and here, for example, CF 186, but usually we don't add the CF. What we're going to add is only fx and frequency. But of course, if you add this, it will not decrease your marks. So that means you can drag this to the right even, and it will not matter. So it is adding the x, it's adding the CF as well. What we need to take are these values only. 1515, and 45. Or you can delete this if you want to. Okay. So here equals 1515 over 45. 33.6666. It's not mentioned how many decimal places, so you can leave it like that. Now let's go to the median. For the median, you have to follow the first two steps, so you can drag this formula down so we can see what we need. So we have to follow the first two steps. Then we can proceed with LMCW until FM. So the first step is the total of frequency over 2. So it equals 45 over 2 because 45 is the total of the frequency. So that gives us 22.5. Step 2, you're going to mention this CF, first number greater than or equal to 22.5, whatever is the answer here. So it means that we have to look at our CF. This is our CF column. Let's remove these colors. Okay. Let's look at our CF column and see or identify the first number greater than 22.5 because we don't have equal to 22.5. We don't have 22.5 here. So we have to look at the first number greater than 22.5. There are many numbers greater than 22.5 there. There are 4, 37, 42, 44, and 45. But we have to look at the first number. First number is mentioned here. So 37 is the first number greater than 22.5 in CF column. So this will be our median class. So basically, the purpose of this step 1 and step 2 is to identify the median class, to identify this particular row. If we are not able to identify this properly, you will have errors here. Okay, so we have to identify the median class for us to get the LM, CW, CFB, and FM. So our LM is the lower bound of the median class. Focus on this class. Our lower bound there is 30. Upper bound is 40, so we have to write it manually, 30. CW is the upper bound minus the lower bound. Our upper bound is 40 minus 30. That will be equal to 10. And CFB, so again, this is 40 minus 30, the upper bound minus the lower bound from this class. CFB is the CF before this median class. So what is the CF before? The CF before is this 18, before the median class. If the median class is this, our CFB will become 0 if we don't have anything above it. Here we have 18 above the median class. So here this will be 18. And FM is the frequency of the median class, that is 19. Frequency or the number of the median class, so that is 19. Now we can find our median. Okay, we use the formula LM. Our LM is 30 plus 10 multiply, that is our CW 10, multiply 22.5 22.5 is step 1. That is sigma f over 2 minus our CFB 18 close our frequency 19. That is our FM. So the answer is 32.368 something. Right, so it's pretty simple. We just have to follow step 1 and step 2. Then we highlight our median class, and then we get the variables and solve. You can also, of course, select. So equals 30 plus 10 multiply open 22.5 minus 18 close divide 19. So you can also select the values. It's the same answer, of course. Now for the mode, we need the first two columns only. We don't need the other columns. So we can copy the first two columns and paste it here. Control V. So we remove these colors. Now in frequency, we have to look at the highest because mode is the highest frequency. Okay, so as you can see, the highest is 19. So we have to highlight this. This is our modal class. Right, so 18, 19, 5, 2, 1. Of course, we don't include the total. The highest is 19. So there, our L is 30, the lower bound. And CW equals 40 minus 30, the upper bound minus the lower bound. So equals 40 minus 30. D1 equals the highest minus above. Above 19, that is 18. So 1, and then D2 equals 19 minus below. Below 19 is 5, or you can write 5. And D1 plus D2 is 1 plus 14. So we have all of these values. So you can now drag the formula. The mode is equal to the lower bound, the L, plus 10 CW multiply D1. Our D1 is 1 and 15 is our D1 plus D2. So 30 is the L, CW is 10, multiply, open and close, our D1 is 1, and D1 plus D2 is 15. So the answer is 30.666. So our mean is 33 point something, median is 32 point something, and mode is 30 point something. They are very close to each other. Okay. So these are the values. Let's now proceed to EX4. So what's the meaning of this? This means that most of the drivers who met accidents last year are age 30 to 33 or 33 point something. So 34, from 30 to 34 approximately, 33.666. And you can see it here, 20 to 30, 30 to 40, we have 18 and 19. So most of the drivers who met accidents are from this intervals, from 20 to 40. Now let's have here our answer. We have to find the standard deviation. So to do this, we have to find the fx, the x squared, fx squared, and our CF. CF, actually, we don't need this to identify identify our standard deviation, but anyway, it is there. You have to complete the table. So fx is to multiply the frequency, and of course the x, our mid interval. 8.5 is the midpoint between 5 and 12. That's the meaning of mid interval. So here, 25 is the midpoint between 20 to 30. That's the mid interval. Here, 30 to 40, the midpoint is 35. So this is with frequency 18 and 19. Two highest frequencies in this data. Here, 8.5 means the midpoint between 5 and 12. And 15.5 is the midpoint between 12 and 19. Already it is calculated. So we just have to get the fx equals the frequency, multiply the x, and drag it down. Now the x squared, that is equal to the midpoint, shift 6, 2. Raise to the power of 2 and drag it down. And fx squared, that is equal to the frequency, multiply the x squared. So please be careful here. Fx squared means the frequency times the x squared, not the x squared of this. And drag it down. And CF, the first CF is equal to the first frequency, and then equals the left plus the first one here above. And select the second value and drag it down. So here we are going to get our sum and select the values. 32 equal to the last CF. You can drag this directly to the right. Okay. So we don't need the sum of x. Can delete that and this. This. We need only these three sums. Okay. All right. So let's now get the mean or the average. All the formulas are here. If not, you can go to x3. You can find the formula of the mean. So equals the total of fx over the total of f. The total of fx is this. This is the total of f. And two decimal places. So you can decrease this. This one is increase. This one is decrease. 19.17. And then we have to get the variance. The formula is here. The variance actually is inside the square root, this whole thing. So that is equal to the total of fx squared. This is the total of fx squared over the total of f. Total of f is 32 minus x bar squared is the mean squared. It's the mean, shift 6, 2. So again, we select the total sigma fx squared, divide the total of our f minus the mean or the average square, because we have here x bar squared. X bar is our mean. Okay, so we reduce to two decimal places. For the standard deviation, that is equal to the square root, SQRT, of the variance. This one, the square root of the variance. Then we decrease 12.58. Now, we have to get the mean minus SD equals the mean minus the standard deviation. This is equal to the mean minus standard deviation. And second one equals the mean plus standard deviation. Now, what's the purpose of this mean minus SD and mean plus SD? The purpose of this is that we are actually assuming that this data, group data here, is normally distributed. I've explained this in the class last time. I have explained this before. When you say normally distributed, it is approximately symmetrical left and right. That means the shape of the graph is somehow a bell curve, approximately. So assuming that the data is normally distributed, we can interpret standard deviation using these values. Now, first of all, standard deviation is the average distance of the scores from the mean. Our mean is 19.17. It means that most of the scores are 12.58 away from 19.17. So that is 19.17 minus this. So to the left, that is 6.59. So that means 6.59 to 19. Most of the values are there. And on the right, 19.17 plus 12.58. So that will be until 31.76. So the large proportion of the, go back to the data, to the information above. The group data below talks about this tardiness. When you see tardiness in minutes of employees in LPQ Limited, tardiness means the number of minutes late. Tardy. Tardy means late. So the large proportion of the tardiness in minutes are cluttered around 12.58 minutes from the mean, from the average, between 6.59 or approximately 7 minutes and 31.76, approximately 32 minutes. So this would mean that most of the employees are late between 7 minutes and 32 minutes. So it could mean that some employees are late within 10 minutes, 15 minutes, 30 minutes, 31 minutes. Most of them are falling under 7 minutes to 32 minutes. And we can also verify this from our data. The concentration of our data is from 7 minutes to 32 minutes. That means many employees are late within these minutes, approximately 68% of them, of the employees of LPQ Limited. Okay, so like we can see from 7 minutes to 32, 7 minutes is here until here. We don't know exactly where because we have intervals. 7 minutes is here, 5 to 12, until here, 25 to 45. Right? So yes, it's true. We have 11, 10, 5, and 3 here. So for example, we have 1 here, okay, because until 32 only. So there might be 1 here, and here we have 5, 10, and here there might be 6, for example. We don't know exactly because it's 5 to 12. And it's mentioned here from 7. So we can still say that most of the employees are here in these intervals. So I believe that this interpretation is correct based on the mean minus 1 SD and mean plus 1 SD. We have 1 here, but we don't need to write it. It's understood. Right, so I hope you understand how to interpret this standard deviation. Now, X5, we're going to get first the variance. Then we proceed to the standard deviation. Then we have the interpretation, then the CV. In number 4, actually, we identified our mean, variance, standard deviation, and we interpreted using this group data. This is a group data because we have intervals from 5 to 12 until 50 to 60. Here, we are still calculating the variance and everything, but we don't have group data like here. What we have is a raw data, list of scores. So we cannot use the formulas here. We are not going to use this formula and this formula also. Sigma fx over sigma f, using this either. So what we'll be using is a different technique. We're going to use functions. So here equals, let's make this bigger. Here equals var, variance of this numbers, then enter. So 3 decimal places as mentioned here. So we can decrease, this is increase, decrease 31.7. Standard deviation equals ST-dev of these numbers. Answer is 5.63 something. Right, and the mean equals the average of these values. 10.89, we can increase this a little bit. So here our mean is sigma fx over sigma f for our group data. Here we have a raw data. The mean becomes equals average. And here equals var. Here equals ST-dev. Right? And the mean minus 1 STD or mean minus SD, that is equal to mean minus SD here, or 1 SD. So equals the mean minus the standard deviation. Answer is 5.26. Second one equals the mean plus standard deviation. So our standard deviation is 5.630 reals. This is about mathematics books, the prices of mathematics books in Omani Reals. So please keep on reading this. So it means that most of the books are 5.630 away from the mean. So 10 minus this, 5.63, or 10.89 plus 5.630. So the large proportion of prices of mathematics books are cluttered around 5.630 Omani Reals from the mean between 5.260 and when you use the word between, you have to use and 16.520. If you're going to use from, so it should be 2 here. From 5.260 to 16.520. But if you're going to use the word between, you're going to use and. So the large proportion of the prices of mathematics books mentioned here are cluttered around 5.630 from the mean between 5.260 until or and 16.520. Now, how can we verify this? How can we verify whether this is true or not? We can highlight our table. We can highlight the table here. And use conditional formatting, home, conditional formatting, highlight, between. There are many conditions there, greater than, less than, between, equal to, text that contains, duplicate values. So between, you select 5.260 and here, and delete that, select 16.520. Okay, so these are the numbers from 5.260 until 16.520. In fact, there are many, except the white ones. So that is the concentration of our data. Okay, now you cannot remove this highlight by changing like this. No. How to remove this highlight? You can undo, of course, or you can go to conditional and then clear rules from the selected cells. Okay. Now, conditional formatting can be used to highlight anything. So if you want to know what are the values lower than the mean, our mean is 10.89, you can select all of this, conditional highlight less than 10.89. You could see that there are, like maybe around 50% lower than 10.89. And of course, the ones not highlighted, the white ones, these are the values higher than 10.89. Okay, and you can undo. Okay, conditional highlight. You can also have greater than. Okay, you can have equal to, text that contains 20, for example, going to highlight all the 20s. Or maybe we have some variables here, assuming this is x, and here we have x. Okay, so you can remove, clear, and then conditional highlight, text that contains x. It's going to highlight the cells with x. Okay, so this is a very important feature in Excel that you can use, and you can use this to find your names. For example, there are some, names, and you want to find your names, I mean, the cells containing your name. In seconds, you can just highlight the table and conditional highlight text that contains, for example, Albert. So it's going to show you immediately all the cells containing that particular name. So you can try to explore this, use between, less than, greater than, equal to, text that contains. Text that contains, specifically, it includes the text, not only numbers. Okay, duplicate values as well can be, then you can have more rules. Yeah, there are many things that you can explore here. Right, so I hope this is clear. So we have here our interpretation of the standard deviation 5.630 using mean minus 1 standard deviation and mean plus 1 standard deviation. Or you can delete the 1, as I said, does not matter. Now, we know that most of the values are from 5.260 until 16.520. And we know that the average distance from the mean of these scores is 5.630. The question is this far or not? The average distance is 5.630. Now, by looking at the standard deviation, we cannot tell exactly whether it is really big or small or moderate, whether the scores are far from the mean or close to the mean, or moderate, normal, not very far, not very close. To answer the question, we have to use another measure. That is CV, coefficient of variation, to tell us whether the distance from the mean is high or not. Okay, so in statistics, we cannot just rely on one value and conclude. For example, you cannot just rely on the mean and talk about the spread of the data, whether they are close to each other or far to each other. Okay, or whether the scores are far from the mean or close to the mean. So we have to use coefficient of variation to finally answer this question. So equals the standard deviation over the mean. That's how to find our CV. So the answer is 51 point something. Again, equals standard deviation divide mean and change to percent and increase. This is decrease, increase. So now you can say the standard deviation is 51.701% of the mean. You can say moderate variation or we call this as dispersion. That means not very far and not very close. The scores are not very far from the mean, not very close to the mean. So how do we know whether it is moderate or small or large? Please try to go to the last sheet. I have here examples when to say moderate from 50, around 50 to 60. You can say moderate. Okay, very small, small, large from these values, very large, maximum. Okay, so try to familiarize this. For Corel, I have given here the values as well, when to say perfect negative correlation and when to say perfect positive correlation. When to say very strong, when to say weak or very weak. So from -1 to 1, -1 is the highest on the left and 1 is the highest on the right. Okay, so that's it. Let's now proceed to EX6. EX6 is actually about the pivot table and pivot chart. Pivot table is a very powerful tool to summarize, organize complex data. Complex data means we have different columns like this. So we can keep on extending, we can add more columns to the right. Even if you have 20 columns or 50 columns, pivot table can easily summarize or manage the data. And even if you have so many rows, even if you have thousands of rows, still pivot table can easily manage the data. Right, so whenever you see the words pivot table, what you're going to do is to select the whole table starting from the first title. First title is SI until price. Don't include the main title, Albay Group, okay, until 14019. Now, in some cases, we have so many rows here. It could be 5,000 rows. So to save time, you have to press Control, Shift, arrow down. Okay. But first, you have to highlight the first row, then Control Shift, arrow down. It will highlight until the last 14019. Right? So again, select the first row that contains all the titles, Control Shift arrow down. The insert pivot table is the first one. So we click pivot table. First, read what do you need. You need the type, the department assigned, and the average price. So click pivot table. Now, when you click OK, it will take you to another sheet. Okay, so click OK. See sheet 1. You have to rename this. Write answer 1 pivot, or you can write pivot table. Now select the type, department, and the price. These are the 3 requirements. As you can see, the type and the department are under the rows here. So it's difficult to analyze it. Everything is placed under the row. So to easily analyze it or see our table, we have to tweak a little bit. So here is mentioned, the row must be type and the column must be department assigned. So transfer the department assigned under columns. This is columns. And you can also interchange in reality. You can put the type under columns and department rows. In real life, it's up to you. But in this particular question, you have to put department under columns and type under row. So now, as you can see, here we have the columns. Okay, we have dining services, housing, police, and security printing services. This is our column, the department assigned. And the type, we have pickup, sedan, truck, and van. That is under the rows. Okay, so that's the beauty of this. In reality, as mentioned in the class, you can play with the variables, with the titles, based on which one you would like to generate, based on the report that you require. It's up to you. So you can play, you can change, you can tick and untick. Now, go back again to the question. It's mentioned here average price. By default, the values will fall under this field, values here. Values, because this is price. So all numbers will be falling under this section. The categories will be under rows and columns. So that is why by default, the price is placed here, because Excel can detect. Okay, type is category, it is qualitative, department is qualitative, price is quantitative. So quantitative data will be placed under this section by default. So you can open this drop down arrow and click value field settings, open, and change to average. There are many measures here, sum, count. By default, it is sum, and you can see here, sum of price. So you can also display maximum, minimum, product, standard deviation, and variance. But our requirement is the average. So, okay. Now, as you can see, it is mentioned now average of price. So this is an average, 14,560. This is an average. This is the average overall. Now, what is this 14,560.125? This is the average of pickup, 14,560.125. How to check this? So pickup is a type. This is under row, so you can go there. You can select the column type and then filter. You can filter the pickup. Okay, so first you have to untick, then select pickup. Now, if you're going to select the prices, these are all the prices. Select, you can see here the average 14,560.125. Now, if you want to change to sedan, then select the average is 19,528.666. Then filter again, 19,528. So you can go there and check, see, it is 19,528.666 for sedan. And it's the same here. Now to unfilter, you have to click filter again to return to the original data. So these values are correct. That is the answer for number 1. Now for number 2, you are asked to insert a pivot chart for the table, for the given table, and add the type, odometer, and the price. Odometer is the mileage, so you can also change that, or no need. Mileage equals this odometer reading. Okay. That's why in front of your steering, you're driving, you see the word odo. It's telling you how many kilometers. In UK and other parts of the world, they use miles. That's why it is called as mileage. So again, for pivot chart, pivot table, you have to select the whole table. So select the first row, Control Shift, arrow down to select the whole table. Insert. The pivot chart is in the middle, not here. The one on the left is the pivot table only. Pivot chart is here, open the second one. Then click OK. It will take you to the other sheet. So rename this as answer 2, or you can type pivot chart. Now, as you can see, there are 2 there. We have the table and we have the chart. Okay. Now, what do we need? We need the type, odometer, and the price. We go back there. So type, the mileage, and the price. Mileage, as I mentioned, is the odometer. By default, as I mentioned, this is sum of mileage and sum of price, and you can change it to average if you want by just opening the drop-down arrow and value field settings. You can change the price as well, value field settings, and change. You can get the maximum and so on. And you can go to design, layout, number 5. If you want to see the numbers, you can make it bigger if you want. Okay. And delete the title here if you want to. Sum of the mileage, sum of price. Okay. So here you can see that the highest in terms of mileage is pickup, followed by the van, and the highest in terms of the sum of price, of course, is the van, 13,000. No, 131,198. So 131,198. Okay, so it's like magic, very powerful. Just keep on clicking. Now, sometimes, this disappears. Of course, you can go to analyze and then click this one, because sometimes, you cannot see. You might change the fields here. See here, we don't have. Even if you go inside the table and click the graph, the fields here, the ones that you ticked, are disappearing. It disappeared. So what you're going to do is click or open Analyze beside this sign and field list. Okay, open. Click the field list. It's going to, because you might be, changing this based on the question, because you might miss something, or maybe you made a mistake, for example. So sometimes this disappears. See, it's nothing there. Even if you highlight or select any cell inside the table. So you have to click Analyze, select Analyze, and click Field List. It will appear again. All right. So I guess this one is very clear. I have done exercise 3, the group mean, median, and mode. Exercise 4 is all about standard deviation, the variance, and the interpretation of the standard deviation. The mean and mean minus 1 standard deviation and mean plus 1 standard deviation. Here we have the same from variance to CV, but we have a raw data different from here because here we have group data. So for group data, we have to use these formulas. For raw data, we have to use equals var for the variance, equals stdev for the standard deviation, equals average for the mean, and here we have to follow the same. Here, x4, we have the same here for mean minus std, or you can have SD is the same. Okay. For the coefficient of variation, it is the standard deviation divide the mean. Okay, so exercise 1 and 2, I solved this last time. So I want you to watch the video about this. And exercise 7 as well. I've solved this already in a different video. So thank you so much for watching the video. And I wish you all the best in your studies and in your future studies. Thank you so much. Until the next time. Bye-bye.